Hi everyone, we are back and we are going to get into lecture 2, defects in materials. So I like to start off this lecture with, this is my kind of favorite, actually I need to delete that, but crystals are like people. It's the defects in them which tend to make them interesting, and that was by Professor Sir Colin Humphreys. But it's actually a very, very good it's a very, very good saying. I always say that, and we're going to see in this lecture, there are a couple things that are always true in materials. 3 statements. Why is this happening? It lowers energy. Why is the material doing this? It's because, or what's the relationship with temperature? Excuse me, Arrhenius, as we're going to see in just a second. And then finally, why is the material doing something cool? Because of defects. Why is the material failing? Defects, 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 defects. The defects in materials, and we've talked a lot about basically perfect crystal structures, but defects in those structures are often what leads to very, very interesting and fascinating material properties. And again, you can see here, we're going back to our old equation. Again, basically, when we at equilibrium, when we're dead, when our energy is essentially minimized and at 0. And we have 2 knobs essentially where we can minimize our energy, entropy and enthalpy, as we've kind of talked about previously. So at the limit, when temperature is 0, we have a absolute perfect crystal. Does that ever happen? No, not really. Even at 0 Kelvin, you still don't really have perfect crystals, although that's kind of debatable or not. But you can have things bond, and you could make this enthalpy contribution negative, or when you increase temperature, you're increasing essentially this that contribution of entropy, which is the number of microstates. So things become less well ordered. They have higher energy. They're trying to basically hopping around, and they will adopt a higher entropic state, which means imperfections, more configurations than just your perfect crystal structure. Because if I just have a perfect crystal where every atom is right where it's supposed to be, the number of configurations, the number of microstates here is just 1. And we know that we know that this is our relationship for Boltzmann entropy here. So that would be a very, very low entropy. But let's say if I included a defect, I added an atom here, I removed one here. Now we've got lots of different microstates that are available to us. And we can actually, so basically, any equilibrium state is going to have some concentration of defects or imperfections. And actually, we can calculate them. We're going to go through a proof of that in just a second. But that is just kind of like our little introduction to defects. And next time, we are going to get into and talk about basically 0D defects. So we'll see you in the next video. And we'll continue on our discussion with, we'll continue our discussion of defects in materials. Thanks. Bye.